Welcome to the show, everyone. I'm your host, Raja Iqbal. My guest today is Bob van Luijt. Bob is the founder of Weaviate, which I consider one of the foremost databases in industry. It is one of the foremost vector databases, in fact. Welcome to the show, Bob.
Well, thanks so much for having me and your kind words in the introduction.
So we'll switch to the general LLM landscape.
Yep.
So in general, when you look at the overall LLM landscape, there are many companies working in the entire, mainly, let's talk about the RAG pipeline and perhaps, in general, the overall, tools and technologies emerging all the way from starting from the models, embeddings, then, LangChain and Llama Index and semantic kernel, for the lack of a better word, frameworks or orchestration frameworks. Then we have vector databases, again, many players out there. Then guardrails, so many things are happening and fine-tuning, and then papers coming out like, Raft, you're doing both, you're fine-tuning, using some retrieval augmentation. So a lot of it is happening. And the fascinating thing is that it is hard to keep up. I mean, so we are the first boot camp in industry, and we have been playing catch up, right? So by the time we deliver a boot camp, and the next boot camp is happening 2 months from now, and then we will have to accommodate so many things, right? So we are constantly playing catch up. Someone was asking in one of the calls, in a customer call, someone said, "Hey, do you teach everything that is the latest and the greatest?" I said, "No, that's not possible for us because we have to have a lead time, right? So because we cannot simply say something came in yesterday and then let's teach it tomorrow in the boot camp, right? So we are living in very interesting times." So which company, beside Weaviate, of course, that you think, or maybe a bunch of companies that you think are going to disrupt things? Any ideas, any companies, any space? In general, I mean, where do you think is the most juice that is out there that needs to be squeezed, or someone who has already figured out where the juice is and that they're trying to squeeze? In general, I mean, where do you think the biggest innovation going to happen?
Yeah. So let me start by answering this question first on like a meta level, if I may, because it's an important question, right? It's an important question. So for a long time, we being the industry at large, were asking ourselves the question, maybe you guys did as well, right? So asking the question like, is this whole machine learning thing, and I'm using the term machine learning on purpose and not AI. So the machine learning thing, is it just a great feature, right? Or is it really like a new industry on its own, right? Is something really new happening? And of course, I mean, as I run a business that sits in that space, I would make that argument for that. But I can even make that argument just, if you're just agnostic of the business I'm running. And that is, if you look in the last couple of decades, the big things were the internet, mobile, cloud. And the reason I would argue that the fourth wave is AI is because we can do some pattern matching. And one of the patterns that we can match is that it's like every time this new era erupts, right, it's a big bang of stuff, right? Frameworks, infrastructure, apps, educational content, whatever you can think of, right? So everything. That's what's happening right now. So we're just after the Big Bang, right? So it was ignited, the Big Bang happened, and that's what's happening right now. So now the particles in the Big Bang, right, need to organize themselves, right? So they need to, for instance, and here we can do some pattern matching again, right? Because, I mean, yes, AI is new, but it's like not everything is new, right? So there's pattern matching we can do. And one thing that we see is that a couple of things are the same. So, for example, infrastructure is the same. The role of data gravity seems to be the same. The role of frameworks seems to be the same. The way how we educate developers and data scientists seems to be the same, right? And let me just say developers as just everybody who writes code. I'm just going to throw them on one pile, call them developers. So how we educate these people and how they learn and the curves that they go through How businesses, enterprises, and startups adopt these new technologies is the same, right? So now, all of a sudden, these pillars starts to emerge and things fit in there. So let me start with the first one, right? So infrastructure, that's where we sit. What's unique are the models, right? So the models, there's model serving infrastructure, the roles that the GPUs play in that, and those kind of things, right? That's extremely important, but we don't know if that will stay. I'm very bullish also on CPU inference. And with the databases, like in this case, for example, we're doing Weaviate, there's data gravity, right? So we still have the data that we enrich with vector embeddings, and there's a form of gravity. Frameworks have a similar function. The problem, no, sorry, not the problem. A challenge with a framework is that because frameworks are stateless, right? It's a little bit harder to build a business around that, right? So if we go back in time, so we look at the previous epoch, if you will, right? So cloud. We also saw that these frameworks were starting to emerge. So you might remember from the front-end days, right? You had Angular, React, those kind of things. And these frameworks tend to come and go because things evolve. So always I remember the days of Angular, how popular that was, right? But now a lot of people use it anymore. And what's so hard is because you don't keep state, right? The value sits in connecting things together and those kind of things, right? So our friends from the framework companies need to somehow figure out how to do that. I mean, and there are companies very successful, but it's a bit harder. And as an infrastructure company, the gameplay is very traditional, right? So it's just the job to be done of infrastructure is make sure that, that there's no data loss, that it's fast enough, that it's easy to operate, that kind of stuff. That's what people pay you for, right? Then education, very similar. We've learned that the world today lives through a bottom-up motion. So through the developers, you grow into the enterprise. Education plays a crucial role in that, so that's unchanged. But now there's something else interesting, and that's the models, right? So what do we need to think about the models and everything we know? Every day there's a new foundational model being released. And what is so interesting, Raja, is that my argument about the models is that are they stateful or are they stateless? They're stateless. Right? So you download a model and then, it's a snapshot in time, if you will. And what makes it very hard with that is that the analogy or the metaphor often that I use an MP3 file. Why is it so hard to monetize MP3 files? The MP3 files themselves, because if I listen to a great song and I send it to you and I said, oh, Raja, you really need to listen to this song, then you have value, I have value, but for the artist to capture that value twice is very difficult, right? That's not the case with a database, because Weaviate is open source. I can download the binary, you can download the binary, but the value you're getting is not from that binary. The value sits in that you want to have a SaaS service, that you want to have SLAs and that kind of stuff. That's the business model, right? So one thing that I expect that will happen is that predict that will happen is that these models starts to merge more with the applications that they ship with, right? And that also go for database. And that brings me to your point about RAG, right? So this is a long way to get to RAG, but some preamble. Because if we look at the original RAG paper and what's happening there is that the argument that's being made is that we do retrieval, we augment the generation by doing retrieval inside the model. Today, the way RAG is being done, it's not that. It's very primitive. It's like the reason that the vector database plays an important role in that is because just the input query is unstructured. So then but then actually what we do after that is very primitive because we shoot it in a prompt and it's very ugly. So bringing my preamble together with this RAG point is that what I believe that's happening, and with Weaviate we do a lot of work in that and we also publish about that, is that we start to, no pun intended, weave the database and the models more closely together. So for example, if somebody goes like, oh, did the large context window kill the vector database? I say, no, because the vector database is becoming the context window. But the thing is, the data gravity part still stays the same. So they come together. And if you want to monetize a model, then the way to do it is a Spotify model today, right? So you have it behind an API. That's great. But there will be a point in time, look at what the great work that the people at Olama are doing, right? Is that just, I can now run these models literally on my laptop. I have an 8 gigabyte MacBook, and I can just run Olama on here, right? So we see where that's kind of going, right? So long story short, I think that's now currently the state is very fuzzy. It's like a big bang where these infrastructure frameworks, now the models as well, and applications are just emerging and floating around in space. But I predict that how they will land is very traditional, right? So what we need to build as builders and the applications we can build with it, that's completely new. But the mechanics, the economic mechanics on how that will land and that kind of stuff, I think that's just going to be very traditional.
Okay. And you mentioned Olama in the context of you can now run a model locally on your laptop, on your MacBook Pro. So that's a very interesting point. So are you suggesting that we are going to be more focused or not in general across industry, but in many cases, we will have what we call small language models, basically a smaller, maybe less parameters, maybe more quantization, some kind of models that are smaller and perhaps more domain specific. Is that what you're hinting at when you mentioned this?
Yes, and the reason, so the short answer is yes. And the reason I believe that is that at the risk of diverging too much, but you might find this interesting. There's this researcher, her name is Neri Oxman, and she did some work at MIT where she created something that she calls the Krebs cycle of creativity, and where she marries together, and the Krebs cycle, comes from proteins, how they evolve or whatever. I'm no expert on that, but the point that she wants to make with that name is that you have art, science, engineering, and design, and they are interlinked together. And art, if you go really way back, right, in history, everything that's happening now with the models, even before large language models, just machine learning in general, comes from analytical philosophy, right? So that's like a kind of artistic, creative way of thinking about it. Then that bleeds into science, and the scientists just had the goal of solving the problem of creating relations in language and proving that there's a relation in the way that the words are structured in a sentence or the pixels in the image, but let's, for the sake of argument, keep it to a language. And out of that came the thing like that the scientists just wanted to prove like, hey, we think by applying attention, we have a mechanism that we can predict a new embedding to get to a new token in a matrix of an array of embeddings. But the engineering part is different. Because what the engineers started, so for me, something like Olama is not a scientific effort. It's an engineering effort. And the engineering effort is very different. The engineering effort is, okay, great, you have these models, there's a bunch of weights, they sit in this binary file here, and to the lens of how an engineer looks at that. So a scientist looks at that, they go like, holy cow, this is amazing. But an engineer looks at it, they go like, ooh, this is really slow. So the holy grail there is like, how can I do this as fast and as cheap and as optimized as possible? So now we see all these, we're now in the Krebs in Neri's Krebs cycle, we're now in the space of engineering, where we're basically saying like, how can we make it faster? How can we make it more optimized? So that's where we are right now. And based on your question, I would say like, so that's the focus. That's why I'm so bullish on CPU inference. Somewhere, I predict that somebody does some kind of an invention by combining certain boosting algorithms together. Then we go like, hey, it's actually cheaper to run this stuff on CPUs than on a GPU, right? And then out of that, we go into design, and then we go to applications. Like, what is the stuff we can create with this? How does a really true AI native world, what does it look like in the application layer? And then the cycle starts from the beginning again. So this is a longer answer to your point, that the engineering mindset is very different, in my opinion, than the scientific mindset, where the scientist wants to solve the problem, and the engineer looks at like, how can we do this better, faster, cheaper, and so on and so forth. And that's where I believe we are right now.
Mm-hmm. So on a lighter note, you mentioned CPU inference, right? So do let me know when you think we are ready, so I can start selling my NVIDIA stocks and start buying Intel stocks, right? So because it would be interesting. I mean, but do let me know ahead of time when it gets closer, right?
It's funny. It's like I was on another podcast and somebody asked me a question. What my prediction was of, I forgot how the question was phrased, but something like, what would you now do in the market? And I said like, well, this is no market advice from me, but I would buy CPU stuff, right? Because these people are, and of course, Intel is also a big enterprise, so that takes time. But we, as Weaviate, collaborate also with Intel, and we see stuff that they're working on, and that's very exciting, and that's speeding up stuff significantly. So these GPUs will go nowhere, because we need them for fine tuning. We need them for foundational model training. So they don't go anywhere. But from an inference perspective, completely different story. But this is production. I could be completely off. But let's do this again a year from now, and then
we'll
know if I was right.
I will bookmark this and I will remind you of this discussion.
Yeah.
So going back to your point about small language models being an engineering effort, right? So there's two things, right? So we can actually build models that are more efficient, more optimized, smaller size, and definitely needed. I think most notably, I think Llama has a lighter, even lighter than 7B version that they released recently. Microsoft has 5. Apple also has those, and I'm sure there are others. So that's there, but there is more scientific effort, right? So on the large language model side, right? So increasing the context window and maybe potentially an infinite context window or very large context window. And philosophically, do you think that it is the context window that is the constraint? Or is it the surrounding engineering that happens? Definitely, I mean, is a larger context window always better? Is GPT-4 always better than GPT 3.5? Just as an example, right? So maybe perhaps a model that has a bigger context window, is it always better than a smaller context window model? What is your take on that?
So the simplistic answer, so please allow me just to first start with the simplistic answer, is like the oversimplified answer is like everything that is a larger context window and that is cheaper and smaller to run and operate is better, right? So that's a given, right? So then the question becomes like, what problem are we trying to solve, right? So if you look at it from a scientific perspective, and this is something I often see that goes wrong when I see people, for example, from a business perspective talk about this. They go like, yeah, but these bigger context window, who needs that? How are we going to sell that? And I go like, yeah, but the scientist doesn't per se care about that, right? The scientist says the scientific challenge at hand is, how do I create a context window of infinite length, right? And we as engineers or business people might leverage that knowledge that is being, the stuff that's being invented by the scientific community to engineer around or to build businesses around. And so the things that need to be solved are like a handful of things, right? So the models are big, let's say clunky. That's a better word, so they're clunky. So we know that they need to be smaller. How small? I don't know. But how small will be determined by the market. They're slow, relatively speaking. So if you do a production use case on it, it's hard to use, right? The way that we interact with the context window is very primitive right now. There's a lot of work we can do to more tightly integrate that together. But that's not the problem our friends from a scientific perspective are solving. So our friends from a scientific perspective are solving what's the least amount of parameters we need to still score high on the benchmarks. What invention do we need to do to make the context window of a theoretical infinite length? Right? The engineers, so for example, people working on Weaviate are asking the questions like, how we speed this up? How do we make this cheaper? How do we make this faster? And then maybe business might be able to adopt this and use it. So long story short, it's a couple of challenges and problems that we have in the models. But what the scientists are solving right now, they have a different point of view on the problem than the engineers or the market has, to adopt that. So I see that as very distinctive things, but if we all couple them together, they need to become cheaper, faster, and better.
Yeah. And then there is this discussion around AGI, and I was looking at a short clip by Sam Altman. He was saying, I don't care how much money we spend, and because we are getting closer to AGI. First of all, I mean, how do you see AGI? Anyone who knows AI under the hood, it is still pattern recognition, right? So, the principle is still the same. So how do you foresee what should or what would AGI look like in your opinion? Is it going to be, well, as the name suggests, general intelligence, or is it going to be AGI for a specific task? I know it's a fairly vague question because there is no agreed upon definition, in my opinion, right now. And what is the biggest barrier? Do you think it is going to be the scientific side that will achieve AGI? Is it going to be scientific effort or endeavor combined with the engineering effort, right? So maybe more optimization, because there's constraints on all sides. There is some algorithmic or theoretical constraints. There's compute constraints and all of that. So I would like to hear from you. What are your thoughts in response to this very vague question?
Yeah. So I love big questions, so I don't mind it. But we need to talk about this. We need to plant a flag in the sand in the form of definition, right? So we need to say something about the definition of AGI, because otherwise we run the risk of running all over the place when we discuss this, right? So and let me know if you agree with this. If you disagree, we can go for something else. But let's just plant a flag now in the sand where we say AGI operates, so is of general intelligence, using the same level of energy and has the same storage capacity and on the same space that it needs to store that information as the brain, right? So, I mean, I don't know these numbers by heart, but it's like, hey, there's like the brain can store, a couple of petabytes and that kind of stuff of information, and the synapses do stuff to retrieve that information, get access to it. It's like, the size of our head is like, what is it, a couple of 100 grams, right? So it uses, the energy that our hearts are generating is enough to power that thing in our head, right? So that's a couple, I don't know, but milliwatts, whatever, right? So let's define it. If we get to that in a digital form, that's AGI, right? So that's the same as a human, learns the same as a human, stores information. So do you agree with that definition?
That's a very interesting definition, because I had never thought about, I always thought of AGI as more from the capability side, not call it the infrastructure side, how much power or how much storage and, what would be the space occupied by AGI. I did not actually really think about it that's a very interesting viewpoint, right? So that's a very, very interesting viewpoint. And I don't have to agree or disagree, because I'm myself actually thinking about what would AGI look like, because, for many of us, AGI, everyone assumes that some generally intelligent machine, but what would that look like? So that's a very interesting viewpoint, actually. I like that.
Yes. Yeah. Well, thank you. And that's why the flag in the sand is important, because the things that we need to bear in mind. So let's take Sam's argument, right? So the reason we need to flag in the sand is because we need to somehow say things about two properties, and that's time and space, right? Related to that, like energy, I guess, right? So, this book or movie, The Hitchhiker's Guide to the Galaxy? and that they have built a supercomputer and they say like, what's the answer to all things? And the thing says 42, and then it needs like many millions more years to explain why that is the answer. So let's say, for the sake of argument, that I believe the number Sam mentioned is 50 billion. And he said, okay, we're ready. We have the whole setup. It's everywhere here. We now got to press enter. We have to wait. We got to spend $50 billion on actually generating, but then we will see a glimpse of AGI because this comes out of the system right now. That is, and that's good for him, potentially bad for the environment. $50 billion spent, but we get to our answer 42, right? Mm-hmm. So that, and then it becomes so esoteric and philosophical that it's great to talk about, but it's very unpragmatic, right? So that is why I like to use the brain, because it says something about energy, time, and space. There's a couple of milliseconds, but if you ask me a question, it takes me a couple of milliseconds to respond. I do that based on stuff that's stored in the equivalent of petabytes in my brain, and so on and so forth, right? So there's a time, space, and energy element to the answers that I'm providing you. And that's that's useful. I mean, not everybody agrees that what comes out of my mouth is useful, but let's, for the sake of argument, say that it's somewhat useful. So, and then having that like on a machine, right? That a machine does that. So then going back to your original question. So the problem is, so if you go back to take that Krebs cycle again, is that I would argue, with the limited knowledge that I have about neuroscience, and this I just have that just as an amateur being interested in that kind of stuff, we don't know. We being humanity, right? So we need to probably go one step back in that Krebs cycle, look at the arts and the creativity in the world to come up with ideas or how the brain might be doing that. So there's like a research I find super interesting. It's called mesh code. It comes from the University of Kent. It's called mesh code, but it's unrelated to software as we're talking about it. And it talks about how a protein called taline might be storing memory, right? And that there's a binary representation in that. And they're now trying to figure out if that's actually how the brain is storing information. And if the answer to that question is yes, then we know how we can get to those petabytes of information. And then we can't read it yet. We just know, like, we see lots of ones and zeros in the brain, but then we don't know how to interpret that yet. But that might be one step forward, right? So long story short, by the time we're there, true AGI, based on that flag we planted in the sand, that's going to take a long time, I think, because we're just not there. What we probably will see happening is that for marketing purposes in the new industry that's emerging, that term will be used, right? So at some point, some GPT model, we see some new architectures now that people are dabbling around with, right? And coming out of that, people will say AGI is reached, but it will probably just be the similar statistical models as that we have now. From a business perspective, a lot of value will be created, right? So I'm not concerned about that one bit. But if you really want to talk about AGI, I think that's not it. And I think the reason that Sam might be a little bit vague about the definition, because as long as you don't have and forgive me if now somebody's listening to this and goes, no, you're wrong, Bob. Look at this page. Here's very clear what the definition, what he means. But as far as I'm aware, that definition is not there. And then what makes it difficult is that we're defining a label, but the definition of what the label means is not there. So we can slap it on anything we feel that fits the bill for the moment. So I hope this is a helpful answer, but I really think that AGI is a term that probably will consumed for marketing purposes before the scientists can really say something valuable about what the definition is, how that thing might work, and those kind of things.
And you think in our lifetime, like next 30, 40, 50 years, or do you think? And that's, and once again, I mean, I know that there's not enough evidence, enough data right now to actually come to a conclusion at the moment. Yes, I mean, we will keep seeing it for marketing reasons, companies will keep mentioning. But in general, I mean, the AGI that Bob would actually consider AGI, do you see that happening within the next 30, 40, 50 years, or perhaps not?
Let me start with the optimistic answer. I hope so. I mean, that would be fantastic, right? I hope so. The more pessimistic answer is that I do not know if the tools that we have available now as humans are currently able to get to actually provide us with that answer. And that goes very deep. So it's like I have an amateur interest in language philosophy. So that's just pure amateur there, but I have an interest in that. And one thing that's happening right now in philosophy is that the question is being asked. And there's a lot of pushback from the scientific community to this philosophical question asked by the philosophers. It's like, are there limits and boundaries to the scientific method that we are currently applying, right? And I find this was kind of born out of the, and I'll bring this back to AI, but this was kind of born out of the question of the multiverse. So that from a philosophical, mathematical point of view, you could say something about multiple universes, right? In philosophy, it's very common to say, like, talk about multiple worlds, theories, and those kind of things. But the argument was like from the physicists was like, yeah, but that's not scientific because we're bounded by the universe we're in. So we don't know how to look outside it to see if there's another one. And that's where the question came from. Yeah, but if we can say something about it, then might that also might that not be enough? So do we maybe need to revise the scientific method that we're using? So I would not be surprised that to get to true AGI, the first principles that we need to go back to is as deep as maybe together as humanity ask ourselves the question, is the scientific method itself sufficient to get this question answered? And that will be a super exciting journey. So regardless if you get there in my lifetime or not, it's going to be exciting. But my pessimistic view would be, I'm not sure if we're going to make that in the time, at least I have left, assuming that I'm that not something super interesting happens on the biological space where, with longevity and that kind of stuff. So we'll see. But the journey will be exciting. But I just don't know.
And journey is already very exciting, right? So when you see the updates and the news coming out every single day, it is exciting. So, please go ahead, Bob.
The nice thing is that the thing that we just discussed is very, very esoteric, right? Very, specific. But the nice thing is that the fact that if we bring it a little bit more to today, so the stuff that's happening with AI now and machine learning, because so much money is being poured into that. That means that at the tail end of that, on the more philosophical, deep scientific end of this whole spectrum, more money flows to that as well. So a lot of work is happening there too. And that is something I'm super excited about. So it's like, anybody's benefiting from what's happening now in AI, but we really need to make a clear distinction between what do we do now as a business, where do we create value for our customers on one end of the spectrum, versus what we have been just discussing completely on the other end of the spectrum. Both super important, but very different beasts, right?
Yeah. So thanks, Bob. I mean, I enjoyed the discussion. This was wonderful. Let's actually go back, or maybe, steer the discussion back to the present, right? So whatever we have, the state of the art. So based on that, Weaviate or any other vector database, they're going to be at the center of a RAG application, right? So a RAG application cannot exist without a vector database. What are some of the actual real challenges that you may have, that you have seen in enterprises when they're trying to adopt a RAG-based solution? And maybe I can extend it to even if they wanted to adopt a fine-tuning solution. So what is the biggest barrier? What are the biggest barriers and risks in enterprise adoption of LLM applications, be it RAG or fine-tuning, or maybe perhaps hybrid? And then a follow-up question is going to be, how does Weaviate help in overcoming those challenges?
Yeah, so I think the simple and the short answer is and again, this is just history repeating itself, this stuff is not a silver bullet, right? So we see people just, throw data at it and then just go like, and now it should all of a sudden should do its magic, and now it's solved, right? And of course, that's not the case. So, sometimes people struggle with chunking strategies or those kind of things, or sometimes the queries that people have just fail to find the right candidates to provide into the rec pipeline. So rec pipeline is successful if the candidates that are selected from the body of data that you have actually contain the answer, right? Mm-hmm. And so those are very pragmatic things, right? So that we see.
And if you allow me to interject, right? These are more of engineering problems than more of a scientific problems, right? So, I mean,
Yes. So what the scientists have done, we can take that now into our world of engineering and create businesses around it and that kind of stuff. That's why all these businesses exist. And that is wonderful. So we do not need, for the sake of argument, we do not need more help from the scientists right now. We're good there, right? So we're now in the engineering world where just the business says like, hey, I have like 50 million, I don't know, contracts in my database. I want to efficiently search through them and understand what like relations are in these contracts. And then you talk about chunking strategies where the frameworks play a role, how you store it in the database, how it's retrieved, how you operate the database. Those kind of things, those are the challenges that you see today. And that goes back to also the great work, of course, what you guys are doing. It's like we need to help people to learn and understand them and to educate them on how to do that kind of stuff. So that's why we all need to work together. And I would say that's the biggest challenge right now. So if I would have to split that into like one, just operational, right? So the market now goes a little bit faster than where most of the pure play vector databases are. Because if people play around, they go like, oh, I have 1,000 documents. And then they go like, okay, now I have like petabytes of documents. And go. And that's the operational side. And the second thing is like education. So how does a vector space actually work? How do we efficiently organize in that space? Why do I need hybrid search? How do I need to organize my filters and so on and so forth? So those are just the very basic day-to-day things I see at Weaviate that people are struggling with, but we're also helping people, right? So it's like it's not a struggle leading to like a negative outcome. It's just like the status quo, but more and more material is coming out, and people are learning, because it's such a paradigm shift. It's so different than what we're used to. Plus, we are also, from a product perspective, are doing stuff. So I'm very, very bullish on this concept of generative feedback loops. I don't know if you're familiar with that, but where we say like, hey, the database can actually do more. The generative model can actually directly interact with the database to help the user organize their data in different ways, or to create data objects or update data objects and those kind of things. And the tongue-in-cheek joke that I always make is that I say with generative feedback loops, we can turn chicken shit into chicken salad. And that is like a completely new thing in our space, right? So that's new. That did not exist. If you threw something in a database, regardless if it was good or bad, you retrieved what you stored in it. And now all of a sudden, by weaving model and the database together, the model can have an opinion on what you've actually stored in your database. So all these kind of things are contributing to all this new stuff and this new market that's emerging. But just things people struggle with today is like, okay, we get it, we see it, we tried it out, we want this. And then in bringing that to production, they have some very basic challenges like chunking strategies, operational questions, and that kind of stuff. But we'll overcome that. We'll be fine.
And so you mentioned generative feedback loop. So does any of the mainstream vector databases at this point, do they offer this? Because I mean, as the engineer in me, or maybe more of an architect in me, I mean, we have a product that we have built. This is something that, I can relate to it. I mean, how can we actually improve the retrieval, right? So Raft is probably you can have a custom model for embeddings and all. So there are different approaches, right? But one thing would be directly impacting the retrieval. So is there anything that you're aware of that actually offers this kind of generative feedback loop?
Yes, we do.
Okay.
But on a serious note, so this is what I mean when I say earlier in our conversation where we're talking about existing databases adopting the vector embedding as a data type, where I'm saying this is great because if the market wants that, that's great. But this is where the big differentiating factor sits between vector search as a feature and being AI native. And let me explain this. Let's bring this all together. Just let me give you a use case example, right? Where you can easily distinguish. So let's say that you have a use case where you have support tickets that are coming in, right? Use case number one, where we see vector search as a feature, is that we might say we're going to create an embedding for this ticket, right? For this support ticket. And we're going to try to predict what label should be attached to this ticket, or what support engineer we want to assign to this ticket, because based on in vector space, we can see what similar tickets were handled by certain people, right? That is vector search as a feature, which is great. That's a lot of value. Sounds great. And the example is, if I would take that out of my support ticket system, the support ticket system would still work, right? It would just not have labels, right? But it would still work. Now you can make a distinction. Do I want to use in like an existing database or a pure play vector database player? And then it's very simple. Depends on like scale, operations, that kind of stuff, right? So if you go like, I'm using database X, works well. I'm just going to add this as a feature. Great. You say, well, a bigger use case, I might want to do pure play. Fine. Too fun. But it's all vector search as a feature. Now, let's take the same use case. So same situation. So we have a support ticket system, and now we do something else. We do create a vector embedding for what's stored in it. We store that in database like Weaviate. But now, because we have a generative feedback loop with a generative model, we instruct the model, use the database to find the answer to this question and provide it yourself to the person who created this support ticket. So no labeling, no nothing, no. Just answer it. That's an AI native use case. And there we need to have integrated RAG. So we really need to have the database and the models woven together. We need to make sure that the model has direct support, direct access to the database. How does it do that? It uses vector embeddings for that, right? And now if you would take that out of the application, my application would just die, right? So then my application is gone, then nothing happens. That's an AI native use case. So the big difference to think about is like, is it a feature where you just do something in vector space, where just vector space is better suited to solve your use case? Great. Then you can use a new player like what we're doing, and there's certain reason why you might want to do that. But you can also do it in an existing database. But if you say, no, I'm building like the new stuff, like the cool stuff, right? The AI native, complete different story, because now you need a database that does this out of the box, that has all the integrations, that is really built for purpose to do that. And that is the big difference in the that we're seeing right now in the ecosystem. And obviously I'm very, very bullish on the second one for Weaviate, because I believe that 5 years from now, 2 years from now, a year from now, we're not even going to think about these models. We're just going to go like, of course, we have a generative feedback loop in our application, right? Of course we'll do that. So we're not even going to talk about it. It's just going to be part of how we build applications, because it's so handy and so helpful. So that is where I believe things are going.
Yeah. And I think you're probably referring to, if I look back during my PhD, right? So early days of machine learning, or perhaps early days of adoption in industry in machine learning, we used to spend a lot of time tuning the hyperparameters, right? So I see the parallels here in terms of, what chunking and chunk optimization and, hybrid search and tweaking the hybrid search, chunk sizes, all of that. It's pretty much the same as what used to be hyperparameter tuning. And then we started seeing these tools evolving and moving more into the, auto ML, or somewhat of a maybe less intense and less human intervention type approaches. Libraries, they've started becoming smarter as we were able to figure out what the real problems are that people are facing.
Yeah, exactly. And I think what's different right now than back then is that we're it seems that we're over the bump of like the uncanny valley of what the models can do. So are you familiar with that concept of the uncanny valley?
Mm-hmm.
Yeah, so let me quickly define it because I completely forgot.
For the audience,
there
for
will be
sure,
listeners. That there will be listeners.
yeah.
No, sorry. Yeah, I was so in the conversation. So for those listening who are not familiar with the Uncanny Valley, it basically says if you create like an old-fashioned robot, then you go like, oh, what a cute little robot, and you can clearly see that's a robot. And then even if they try to become like a humanoid robot, and then there's at some point, then there's a robot that looks like a human, but it's just not a human. And then people are scared of it. They go like, ooh, how scary. And that's the uncanny valley that we need to go through before that it's like a truly humanoid robot. And that uncanny valley, in my opinion, also exists for these ML models, right? Or these AI models, in the sense that I remember that we saw the first models that were doing predictions. I mean, I believe there was a model from Microsoft called Gödel, I believe, or something like that, where it was like predicting new tokens, but it was kind of crappy. And you were like, oh, that's so sweet, right? So it's like, it's almost there, but it's like, it's completely useless, right? So it's like a robot that just drives around and doesn't do anything, right? So, but it's like kind of sweet. And then they improved these models, but we might remember that I believe it was also Microsoft who created this chatbot, which basically said horrible things, right? To people. And
they released it on Twitter.
Yeah.
So
Yes. And now we're at the bottom of the uncanny valley. That people go like, well, if this is what AI is and what it can do, then no, thank you, right? And what happened with ChatGPT was that we were out of the uncanny valley. We started to anthropomorphize with the models. That people were saying like, hey, the model is talking to me, right? I remember just after it was released that I was listening to a podcast where they were interviewing people who were like very shy or didn't have any friends, who were talking to the model, and that the model was their friend. So out of the uncanny valley. And from a business perspective, right, coming out of the uncanny valley meant that all the things that we could do now with vector embeddings coming out of the models were not only a feature, it was a new thing on its own. We really could create now AI products, or again, what I like to call AI native, because the models were out of the uncanny valley. They were good enough. And that is new. So the new thing is not having a new data type that we can search with, because we're doing that now for a couple of years already, and people got a lot of value from that, but it was just a feature. The fact that the models were out of the uncanny valley meant that we could build completely new AI native applications. And it happened to be the case that the infrastructure in the form of vector database to support that existed, right? And that is really the new thing here, how people are, in my opinion, building. And that's the big difference, I think.
Thank you, Bob. This was very insightful. Thank you for being here and taking the time to talk to us.
Of course. And thank you for the wonderful questions. I really enjoyed it.
Thank you.